Okay, so today what we're going to be doing is we are going to be looking at tree diagrams in our probability. So let's have a look at this example here. Or the key things we're going to look at. So a tree diagram can be used to list the sample space of experiments involving two stages. So what we're going to see is we might select, say, 2 cards from a deck of cards, or there's going to be 2 things, and we're going to work out the probability that, say we had a deck of cards, so we take what's the probability that we draw an ace the first time, then we put all the cards back together and you draw another card, and maybe we look at the probability that we get 2 aces in a row or whatever like that. So each outcome for the experiment is obtained by multiplying the branches. We'll see this in a minute. So we'll see, like, we branch it out and we give the options. So let's give an example here. So we're going to say we've got an example. That's right. We've got 2 counters. So say we got are selected at random. So we're just going to not look at it and collect. We've got counters in a bag. Select at random from a bag with replacement. So with replacement means, like, even though we took one out and we got an outcome, like we got a result, and then we put it back in, and then we did that again. So we're replacing it back. So say, for example, so we had this bag. So I'm going to draw this bag. We've got this little bag, and I'm going to say we've got 1 green counter in this bag, and I've got 2 pink counters in there. Okay, so what happens in the tree diagram? So we've got our first selection. Okay, so if you think, you write all the outcomes that it could be. There's 3 options I could have got. I could have got a green one, or I could have got one of the pink ones or one of the pink ones. So that was my first selection. So we had the bag there. Sorry. So here's our little bag. So with first selection. And then we say we'd have the second selection. Okay, so we put the counter back that we picked, but we go and we do it again. So when we do it again, we have that same option, 3 options that could have happened. So we could have, as we said, we could have got the green one, or we could have got the pink one, or either one of the pink ones. Okay, so what this goes, if we draw this tree diagram, we'll end up with, that's the second, we'll end up with the results or the outcomes of what we could have got. So what we mean by that is we could have gone this way of the tree at the top branch with the other top branch. It means we would have got a green and a green. That could have been one combination I got. And then I could have got the green in my first pick, and then I could have got the pink one. And then also I still could have got a green on my first pick, and then a pink one on the second. So that was me following. If you look, I went like that, and there, see? And I followed that path. Okay, so then we keep going down. We still had other options. What happened if I got the pink one first, and then I got the green one? So there, I could have had that option, or I could have got pink and pink, and pink and pink. And then I've got this final bottom branch. I could have started off with pink, and then my second one could have been the green, and these 2 pinks. So if you look here, this is how all our outcomes. So I've got 1, 2, 3, 4, 5, 6, 7, 8. I've got 9 possible outcomes. So there's 9 possible outcomes that we could have got. So you could see, right, if I said, what's the probability of a green and a green? So what's the probability of me getting 2 greens? There's only one option, isn't there? Yeah, there's only one. So I would have said 1 out of 9. Yeah, and so what happened if I said, what's the probability of, say, 2 pinks? Well, there's a couple more options there, isn't there? There's 1, 2, 3, 4. So we could have said the probability be 4 out of 9. Okay, so if we looked at that, so we can see that, but say at the start, in my first selection, if I was going to go along the green one, would you say I've got a 1 in 3 chance of getting that green one? Is that true? Yeah. And then I've got a 1 in 3 chance again of getting that green one. Is that true? When we go that way. So you can see when you do a tree diagram, if you were working out the probability of this option, what you do is you can do the probability of the first selection by the probability of the second selection. So 1/3 times 1/3. Now, do you remember when you do fractions, you times across the top? So 1 times 1 is 1, and you times across the bottom. 3 times 3 is 9. Is that what I end up with? Yeah. So there's a way of showing, like the tree diagram can show the probability, but we could also, if we, instead of having to write out all the outcomes, we could have just found the probability by timesing those 2 probabilities together. So that's what we're looking at today. So So let's keep going and have a look at these questions to help us understand. So a box contains 2 white counters. So here's our box over here. 2 white counters and 3 black counters. A single counter is drawn at random. Find the probability that it is white. So the probability that it's white, how many whites are there? 2 out of total of 5. So what's the probability of black? Is 3 out of 5. Okay. 2 counters are drawn at random. Okay, so they're just going to say that. The first one is replaced before the second one is drawn. So that's like before. So they're going to say you've got the same amount of options. Find the probability that the second counter is white. So if you thought about find the probability that the second counter is white. So if the probability it's white on your second counter, would that not be 2 out of 5? Yeah? Because you're at your second choice, you've got 2 out of 5. And what's the probability that it's black on your second counter? Like your second draw. Because you put them back in. Isn't it the same option? Yeah, it's still 3 out of 5. Okay, so 2 counters are drawn. The first counter is not replaced. So this is different. So we've got to be careful this. They're not replacing it. So the second one is drawn. If the first counter is white, what's the probability that the second one will be white? So if you think about it, you don't have to draw this, but first of all, we took a thing out. So then this guy was white and it's not in the mix now. So what's the probability of white in my bag now? 1 out of what? There's only 4 there now, isn't there? So we would say 1 out of 4. So what about the probability that it's black? It's still 3, but it's out of 4. So there's how we can see there's a difference. You've got to be careful and make sure that they don't say, if they say it's not replaced, we have to make sure we're careful. So let's have a look at filling in these tree diagrams. So what they're showing you before, remember I said the probability of this first choice. So they said 2 prizes awarded to a group of 3 cats and 5 dogs for a best in show. State the missing components. So three awards are given. So A, they want to show us with replacement. So that means we've got the same outcome. Same total outcome. So what they mean by that, when they do replace it back, see how this is still 8 and 8. Okay, when we have without replacement, you'll see that the number changes. So we'll have a look at that in a minute. All right, so altogether I've got 3 cats and 5 dogs, so there's 8 altogether. So I've got 3 cats times 3 cats. So what's the probability of picking a dog out of this? How many dogs are there? 5 out of 8. So we could say 5 out of 8 there. And same down here, we could say 5 out of 8 for the dogs. If I was going along here and picking a cat, we know there's 3 cats. So 3 out of 8. So when you can see they're working out the probability, they're working the fraction by the fraction. So this one would be 3 over 8 times 5 over 8. So remember, with fractions, you multiply across the top. So 3 times 5 is 15, and you multiply across the bottom. 8 times 8 is 64. We'll just leave. We can't simplify that, so we'll leave that. This one would be, this option would have been a dog first and then a cat. So it would be 5 on 8 times 3 on 8, which is still 15 on 64. And this one would have been a dog and a dog. So it would have been 5 on 8 times 5 on 8. So we end up with 25 over 64. Okay, without replacement, the first option is going to be the same. We're going to see we've got 3 cats and it's out of 8. Now, if a cat's already been chosen and it's not replaced, how many cats have I got left? I've got 2 and it's only out of 7. Is that true? So we could then work that out. We could say, all right, the probability of a cat and a cat without replacement would be 3 over 8 times 2 over 7. So multiplying across be 6, and 8 times 7 is 56. Okay, if we had a cat already selected, how many dogs have we still got left? 5 out of 7, because we're not replacing it. So there's now 1 less cat. So this would be a cat and a dog. So 3 over 8 times 5 over 7. So that'll be 15 over 56. This one would be a dog cat. 5 over 8 times 3 over 7. 15 on 56. And the dog and the dog. If a dog's already gone, there will only be 4 dogs left. So it'd be 5 over 8 times 4 over 7. So it'd be 20 over 56. You can simplify them if you want, but we'll just leave them as 56. That's okay.